officially on. Everyone say hi. Hi, Michaela. All right, this is just for you, Michaela.
Say hi,
Hi.
It's your partner. You better talk to her. All right. We are picking up on that sheet we left off yesterday. So we're attacking the horizontal asymptotes, which was the limit as x approaches infinity. Okay, so we said every time we see an infinite limit, we've got to be thinking a power fight. Okay, so the three things we could see was a small over large degree, same over same, or large over small. And we said we just have to be super careful when we get the infinity sign because we have to determine whether it's positive or negative because it's one of them. So I think we were on the back side. We attacked a couple of these. Let's go to C here. Okay, so I want to figure out who the biggest term on top and bottom is, or biggest power. So who would we say on top? 4x squared, and it's sitting under a radical. So it's radical 4x squared. Just to be clear, you have to take the radical with it. So I'm ignoring the weak ones here. We're just taking the highest power. And on the bottom, I have a 7x. Okay. So think about what you know about radicals. What does this actually become? What does this turn into? 2x. So I'm going to get 2x over 7x. So I'm getting same over same power, so ratio of the coefficients for my limit there. Okay, but as you pull out that first term, make sure you take the root with it. Let's skip to F. Okay. Oh, that's okay. Actually, I'm going to come up and just verify these powers as well. If I plug in this infinity power, I'm getting a positive. I'm just going to make a note, a positive over a positive. So that's the reason that it's still positive. So when I look at F, the largest power on top is the x squared term, and it's under the root. So again, I'm going to pull out root 4x squared. On the bottom, our largest power is still x, so I'm going to take that 7x. So it kind of feels like we're getting the same answer. That's turning into 2x over 7x. But now this limit was as x approaches negative infinity. So I want you to kind of highlight or bubble this one in. This is where we have to check it. If I plug negative infinity in here, what type of number do I get on top? On top, positive because we're squaring it. And on the bottom, a negative. So I'm getting a positive over a negative. So in this case, the answer is going to be negative 2/7.
If it did end up being negative, would it just be imaginary and form a radical?
No. The calculus world does not deal with imaginaries whatsoever, so don't even worry about imaginaries. Give me 1 second, Braden. All right, look at E. Check my middle desk drawer there and see if I put it in there. All right, we need the largest power on the top and bottom. Oh, now this one's a little tricky. Okay, so we're approaching negative infinity. So think about this. If I plug in negative infinity, I'm going to get 4 plus, and write this down, 2 to the negative infinity. Okay, so in Algebra 2, we are humming with exponents this week. What does a negative exponent turn into? A fraction. So this is really 4 plus 1 over 2 to the infinity. Okay. Now I'm going to do the same on the bottom. If I plug in negative infinity in, I get 2 to the negative infinity minus 3. And again, that's going to become 1 over 2 to the infinity minus 3. So now when I'm looking for a power fight, I'm looking for the biggest term on top and the biggest term on bottom. 1 over 2 to the infinity, what type of number is that getting close to? It's getting close to 0, right? If I had just 1 over 2, can you picture what half a pizza looks like? If I changed it to 1 over 4, can you picture what a quarter of a pizza looks like? If we did 1 over 10, your slice is getting smaller and smaller. As the denominator gets bigger, your piece of the pie is getting Smaller. So the largest term on top, this is getting close to 0. The largest term on top is actually a 4. And this is also getting close to 0. So the largest term on the bottom is a -3. So this limit is approaching 4 over -3. Okay. This question was asked one year on the AP exam, and it was the lowest scoring question of all time. It might have had like a 2% correctness from all of like every student that took the exam. So they ended up throwing it out, and they said they were going to make an example of it, and they've asked it several times since then because it was such a missed question. Horizontal asymptote. So again, I'm just going to highlight here. The second they ask for a horizontal asymptote, you're thinking the limit as x approaches positive infinity and negative infinity. You have to remember to check both sides. So again, that's all this is saying. We check both the limits with positive infinity and negative infinity anytime we're asked for a horizontal asymptote.
It says or there, right? So does that mean that you have a horizontal asymptote that only goes on one side?
You technically could. I'll find a graph for you in a little bit. Tackle A and B here, or A and C. A and C. We're looking for horizontal asymptotes. So you're telling your brain, I need the limit as x approaches infinity and the limit as x approaches negative infinity. And write them each out. The limit as x approaches infinity and the limit as x approaches negative infinity. And find them both. All right, so infinite limits, we're just saying power fight. Who's our biggest power on top here? X squared, biggest power on the bottom. 3x squared. So I see squared over squared, I see same, I'm thinking ratio of the coefficients. Now I just got to check my signs. If I plug in positive infinity, what type of sign am I getting on top? Positive, and on the bottom, positive. So I'm going to say this answer is the ratio of positive 1/3. When I check negative infinity, it's the same function. It's still ratio of the coefficients. I just got to check the signs. If I plug in a negative infinity, I get a positive. And on the bottom, I'll also get a positive. So this limit is also 1/3, okay, for both positive and negative infinity. So it's the same on both sides. On C, largest power on top is 3x. On the bottom is the x squared term, but it's in the root, so we're going to take that whole thing, root 5x squared. Okay, and then we'll try to simplify a little. Obviously, the square and the square root are going to cancel. Do we know the square root of 5? So we're going to leave it. We're going to say it's 3x square root of 5x. Okay, because I don't know the square root of 5, but I do know the square root of x squared. Okay, so it has something to do with this. So ratio of the coefficients, again, is going to get me 3 over root 5, but I have to first determine if they're positive or negative. So if I plug in a positive infinity in my original, I'm going to get a 3 times infinity is a positive, over if I square it, I get a positive. So this is going to be positive 3 over root 5. If I plug in negative infinity, on top I'm going to get a negative, but on the bottom I'm going to get a positive. And again, I'm using this one here, the original one. So this answer on this side would be a negative 3 over root 5. So again, when you're doing these limits as x approaches infinity, you just got to be careful on the signs. Plug the infinity in to determine if they're positive or negative. Okay, so that kind of cleans up, hopefully, all the horizontal asymptotes. And I think we'll add to the cards shortly. All right. So before I forget, that's not in the right book. Before I forget, page 39, at the top, front only, okay, will be one of our homework assignments today. It really shouldn't take long. It's just quick power fights. Large over small, same over same, small over large. Okay, page 39, front side only. Okay. All right, flip the page though. We have to tackle our first theorem. So I'm going to grab a highlighter because there's a lot going on in here. All right. We basically have 2 theorems all year, and we're going to get the first one out of the way. Because it's a big one and we're going to use over and over. So kind of like going back to geometry where you had to write like a statement for all those proofs you do. You have to write a statement for the theorem. Now the good news is it's the same statement every time. You just kind of change the numbers. But you have to write out a pretty good statement each time. So this is called the intermediate value theorem. We typically abbreviate it IVT. You're allowed to do so on the exam as well. So here's the question here. Suppose you were 4'6" tall when you were 10 years old. And now you're 5'7". Was there a time in your life where you had to be 5 feet tall? If you grew from 4'6" to 5'7", did you have to hit 5 feet sometime? Yes, Dree. Dree, you can't argue this. At some point, you had to hit 5 feet.
I'm just saying, would it count if it was like growth spurt overnight? Where basically you instantly went from a number to another.
You hit it at some point in time. Okay? So this is the concept behind the intermediate value theorem. Okay, now a couple things have to be true. So if f is continuous on the closed interval, okay, every sentence is going to start like that. So again, I'm going to highlight this. You have to state you're continuous, and you have to be on a closed interval. Okay, now you can write out the words closed interval. What I like to do is just use the closed bracket. Okay, I'll typically just do that. Where f of a does not equal f of b, and k is a number between f of a and f of b, then there's at least one number in C and ab such that f of c equals k. Once we do a few examples, writing this out is going to seem a lot more smoother than that. Okay. The IVT is about showing a point exists between 2 values. Important notes about the IVT. The IVT is called an existence theorem. We'll learn 3 of these theorems in AP Calc, 2 really big main ones. When using a theorem, we first must show that the conditions are met. Okay? So the first condition is that the function must be continuous on the given closed interval. I'm just going to make a note again. It has to be a closed interval. The y value we want to guarantee must be between the y values of the endpoints. Okay, so the endpoints in this example were 4'6" and 5'7". The number we found between them was 5 feet. AP problems, and this is good to note, rarely explicitly say use the IVT. They're not going to like knock on the door and say it's time to use the IVT. You have to recognize the wording of it. Okay, it's really important that you recognize the wording. And here's the words that kind of give it away. Must there be, can you guarantee, show these must be met, and does a value exist? All of those imply we're going to use the IVT. All right, so applying the IVT, find the function values of the given interval by plugging values into the function. Show the requested y value is between the two y values at the endpoints of the interval. Make sure the function is continuous on the closed interval. And invoke the IVT by using the following conditions. So since f of x is continuous on the closed interval AB, then you need to state the name of the theorem. So I would say the IVT guarantees, and then literally reword the question. Okay, we're going to do a lot of just rewording the question. And again, I will show you how simple this is, but it is a little bit of writing. It's the most writing we do in AP Calc. Okay. The function f of x is continuous with selected values of f of x shown in the table. So the first thing you want to highlight is that f of x is continuous, because none of this works if the function is not continuous. And 99% of the time, they just come out and tell you it is. Is there a value c between 1 and 7? So some place between 1 and 7 that f of c must equal 0. Okay. Justify your answer. So think about this. I know a couple points. I know at 1 I'm at -2, at 3 I'm at 1, at 4 I'm at 4, at 7 I'm at 6. I'm a continuous function. I'm just going to graph out what that even means. So again, at 1 I'm at -2. At 3 I'm at 1. I'm just going to ballpark these. At 4 I'm at 4. And at 7 I'm at 6. Okay. Now, I know your gut probably wants to connect them and make like a straight line, but do we know it's a straight line? So I'm just going to draw something random. I have no idea what this thing looks like. I just know it has to hit those points. I know it starts here, it ends here, and it has to hit those points. So the question is, does the function ever have to hit 0? Are we guaranteed we will hit 0? Yes. Why? How do we know we have to hit 0? How do we know it's going to pass through the x-axis? Exactly. We have a negative y value, and then we have a positive y value. So at some point, we have to hit 0. Now, do we know where that point is? No, we're never going to know. We just know that it's going to happen at some point. So to answer this question, is there a value? Our answer is yes. Okay, we're going to state the first condition. F of x is continuous on the closed interval, and we're continuous from 1 to 7 in this case. Okay. So again, I'm just going to flip back for a second. We're stating that the function is continuous on the closed interval, just like it says, whoops. And then we're saying the IVT guarantees, and we're going to repeat the question kind of. All right, so then we're going to say the IVT guarantees so what were we trying to guarantee? That f of c will equal 0. And now we're going to tell them where it's going to equal 0. So I'm going to say since, and we're going to describe the 2 points that Luke mentioned. We knew this was at -2 and this is at 1. So I'm going to say f of 1 is less than 0, which is less than f of 3. Right? Because we knew f of 1 was -2, and we know f of 3 is 1. So we know that this has to happen. And that's it. That's kind of our proof, so to speak. Okay, but you need these certain things in there. You have to answer the question. You have to state that the function's continuous on the closed interval. You have to name the theorem, repeat the question, and show where it happens. Okay. All right, example 2. Use the intermediate value theorem. So again, it's never going to come out and say that. These are just examples. To guarantee that this function g of x has a 0 on this interval. Okay, so let's first of all, what does it mean to have a 0? Crosses the x-axis. So g of x will equal what number? 0. So we're trying to show that g of x will equal 0. Okay. So I've got to find some points basically, and they're telling me to look between 0 and 1. So let's figure out what g of 0 is. I'm just going to substitute in 0. So I've got 0 cubed plus 2 times 0 minus 1. So g of 0 is just going to be -1. And then I need g of 1. 1 cubed plus 2 times 1 minus 1. That should get me 2. Okay, so think about what we're saying. At 0, I'm at negative 1. And at 1, I'm at a height of 2. And again, I have no idea what this function looks like. My gut always wants to draw a straight line, but we really don't want to do that. It could do anything. But am I guaranteed to hit 0? Absolutely. Okay, so we're going to say since, we're going to have to say since, but since g of x is, now how do I know it's continuous? What type of function is this?
It's not a piecewise function.
Not a piecewise function. We'll just call them polynomials. All polynomials are continuous. So since g of x is continuous, and again, we got to state the interval on the closed interval 0 to 1. Then we just use the same statement. The IVT, intermediate value theorem, guarantees g of x will equal 0. And then we want to show the greater where, since g of 0 is less than 0, which is less than g of 2.
Shouldn't it be less than g of 1?
G of 1. That sounds better. Yes, g of 1, because we tested 0 and 1. Thank you. All right, so we'll typically, I would say the way they ask them the most is in this tabular way in a table. I guess this would probably be the second most, and then we're going back to a table. They like to ask these in a table. So let's try one more together here. Let m be the function given here. I'm just going to highlight that for myself. Can you guarantee? Okay, so there's one of the key phrases I'm just going to go back to for a second. They're usually going to say, must there be, can you guarantee, show there must be, does something exist? Okay, can you guarantee that m of c will equal 4? Okay, so in my head I'm saying if m is going to hit 4, then there has to be a number below 4, and there has to be a number above 4, then I'm guaranteed to hit 4. Now, what numbers do I want to check? Well, they're telling me the interval from 1 to 9. So I want to find m of 1, and I want to find m of 9. Okay, and m is k of h of 1 and k of h of 9. So I'll give you a minute to evaluate those. K of h of 1 and k of h of 9. A little composition working backwards, big algebra 2 stuff.
When reading a first statement, should we say since m of x is continuous, or should we say because h of x and k of x are continuous?
I would probably say they're telling us h and k are continuous. Yep, you could, I think I would say h and k. All right, what did h of 1 turn out to be? 5. And then I need k of 5. K of 5 is 7. Perfect. Then I need h of 9. H of 9 is 2, so I need k of 2. K of 2 is going to get me a 1. So am I guaranteed to hit 4? Yes. And again, this is all this theorem says. So can you guarantee? So I'm going to say yes. They told us h of x and k of x are continuous. And again, it's always the closed interval. Think continuous closed. Continuous on the closed interval. Then the IVT, Intermediate value theorem guarantees. Repeat the question back. What are we looking for? M of C to equal 4. And then where it happens, since, okay, so just write your inequality the correct way. Who would I write first? M of?
I wrote it just as greater.
Just greater than? Okay, I'm going to go less than, but M of, but you're fine. M of 9 is less than 4, which is less than M of 1. If you went the other way, M of 1 is greater than 4, which is greater than M of 9. All right. So again, all it says is if somebody is smaller than you and bigger than you, at some point you had to hit the middle. And again, it has to be because the function is continuous. Or,
Not continuous.
then it's not, it could happen, but it's not guaranteed is the key. All right, go ahead and try, I don't know, 1, 2.
Is this a homework?
I don't know what it is. Try 1 and 2. I'm making it up as I go, Dre. Perfect sentences. Piecewise, you don't know. You'd have to show the theorem, the left side, the right side, and F of. You gotta use the continuity definition. Yep, the definition is okay.
Repeat them.
All right, so yeah, just walking around, we want to just be really specific between where we think that value is going to occur. Some people have just a broader range, and we just want to hone in on where it's going to happen. So it looks like everyone said, so must there be a value? Yes. where, between what two numbers am I going to hit 8 for sure? Okay, so between these two values, you could box them in, right? If I went from a height of 2 to a height of 9, I have to hit 8. Okay, so my answer is yes, of course. We're talking about function f of x, and they told us it's continuous. Is continuous on the closed interval 1 to 8. The IVT guarantees. I'll just repeat the question. F of c will equal 8. Since, now again, I want to be specific. F of 7 is less than 8, which is less than f of 8.
So my question was, why does it have to be specific? Because it's still guaranteed between the two numbers, even if you're not being specific.
You just want to hone in. There's got to be a better reason than I'm giving you right now. You definitely want to hone in on the section that you know what's happening between. It could happen more times than here, but it's guaranteed to happen between these two for sure.
It's also guaranteed to happen
That is
between
true, that it
numbers.
is going to happen someplace on that interval. Let my brain think about that as we keep going. But for now, yeah, let my,
I just put the interval it gave us.
yeah, and based off like the AP answers, you always want to hone in on that section. I agree with you, it's definitely true in there. Let my brain keep thinking about this definition if there's more to it. With that being said, yep, I'll go over 2 in a second. Go get 3 if you're done. Good work walking around there. Just talks out that first one, number 2. They told us the V of t is continuous, so that's fantastic. And does V of r, so here's my V of r, V of t line, have to hit 0? And definitely it does, because we have a positive to a negative value. Just make sure you put them in the correct order, of course. So yes, V of t is continuous on the closed interval 0 to 10. The IVT guarantees that V of r will equal 0. Who would I put first if I'm going least to greatest? V of 10 is less than 0, which is less than V of 8. Okay. All right. Flip to the next, or the back side there, number 6.
I think 4, because I was working on that, answers my question familiar, kind of. Because
Go ahead.
g of negative 3 is 2 and g of 9 is 12, which in between there isn't 15. But
That's
g
true,
of 1
right.
is 19.
Correct. So it does have to happen in an interval, just not that entire interval.
Mm-hmm.
Yep, I like that. All right, number 6. The table above shows selected values of a continuous function from 0 to 13. What is the fewest number of possible times that f of x has to hit 4? So it obviously could happen more than once, so carefully scan it. We want the fewest number of times that it has to hit 4. And again, these are just possibilities. Leo, give me one time where you have to hit 4. Between what two numbers do you have to hit 4? 0 and 4, 100%. Mallory, did you find a second time? Yes, between 4 and 6, because we're going from 4.5 to 3. Anyone find a third time? Joey? 8 and 13? Yep. I'm definitely guaranteed to hit 4 as well. So in this case, I would definitely say 3. Again, this is just an old AP multiple choice question. I think it's fairly nice. Now, if this was in the short answer question, just to be clear, you'd have to write out all 3 times that it happened in the write-up, okay? All 3 times. All right, let's see. We've got, I don't even know what this class ends. All right, we're going to finish. So just to be clear, let's put homework on this page. We're going page 43, anything we didn't finish on this page. So front and back of that. So I don't know where you're at. And what was the other one we said? Front only of 39. Okay. So front only of 39 and page 43. Say that again.
Are we going to do the flashcards?
Yeah, let's do the front and back of 43. Sorry again. I don't know, when does this class end? 05. We're going to do it Monday. Okay, we'll get those flashcards done Monday. So we're definitely heading toward the end of limits. I think there's only one day left. So we'll go 1 day review and then test Wednesday. Does that make sense? 1 day. We have one last limit lesson, review, first calc test on Wednesday. Clearly all on limits.
How much time's left in class?
What's that?
How much is left in class?
A minute.
I'm not going to get stuck on something here.